So if you are landed on this video, so let me tell you this is the best explanation of RIP protocol that one can give. So in this video we'll break down each and every bytes of the RIP protocol. So without wasting much time, let's get started. So before we start this video, the first thing that everyone should know about this video is this is not something RIP basic introduction video. So for this video, for you to continue with this video, you must know something about RIP, at least the basic of how is like what is the packet format of RIP. And if you don't aware about that and you might want to watch a video of RIP basics, so I have made a full video on RIP basics. So I'll link down that video probably in the I button over here or in the description box, so you just go and check that out video first. So if you are ready to go ahead with it, so let's get started. So the first thing that you are going to see over here on this page is everything works on multicast but it is blind. So we are going to see RIP routing scenarios but with this sentence in the mind. So I will explain this sentence. So once we see the routing scenarios, this sentence will be clear. So let's get started. So there are some routing scenarios. So the first one is full routing update request. So the only one entry in the routing update asking for all the routes. So basically this is the specific RIP scenario. So basically the specific RIP packet exchange. So let's just see an example. So this is the Wireshark of particular scenario. The scenario is full routing update request. And as I said, it is nothing but a router, a particular device asking for all the possible routes that device can have. So there are plenty of things that you must note. So about this packet, first we can see the source address. So this is a device that is asking for all the routes, and how we can determine that whether it is a full routing update request kind of packet. So the first thing that we must note is destination address should be multicast. Then inside this RIP packet or RIP section, we should see the command request. Basically the value of that particular field should be 1. Then we should have only one address, which is also needs not to be specific, like not any specific address, just all the entries over here should be 0 with the metric value being 16. So this is the kind of packet that you might see for this particular scenario. So let's move ahead. So the second scenario is partial routing update request. So as I said, this will be a request kind of packet. So command value should be 1 or more than one network in the routing update asking for update. So there might be a case that a router might need certain entries. So the case for that is, let's say a device might have exceeded the timer for that entry, so it might ask again for that entries, and with that we might have some other entries. So let's just see the packet format for that particular scenario. So this is the Wireshark capture again, and there are certain things that you must need to know about. So the first thing is source address is the device that is being asking for the routing update request. Then the destination address should be multicast, obviously, because it doesn't know that where are these entries or which device has these entries. So obviously the destination address should be multicast so that each and every device can process it. Then we have something called the command inside the routing RIP format, RIP header. It should be 1. Then followed by the particular, let's say there is here in this packet there is only one entry for this 10.10.14, which is being sent, but also it is asking for all the route updates. So there might be a case where this can be a particular network, but partial routing update can also include the routing entries. Let's say it can also ask for all the routing updates. So whichever device uh, will receive this packet, it will add the routing entry for this particular route, and it will send all the entries to this particular destination 10.10.11. So that is the partial routing update request. Then we have something called route poisoning. So route poisoning is nothing but the acknowledgement for the failed routes. So how a device that are communicating with the RIP, they will withdraw the routes. So that is nothing but route poisoning. So let's just see a packet. So again, this is a Wireshark packet capture for the particular scenario, route poisoning. So there are few things also over here that you can distinguish. So the first thing is source address and the destination address. As always, destination address should be multicast because it is withdrawing the routes and it doesn't know there are how many devices. So each and every device can receive this packet. That's why the destination address should be a multicast address. And in this case, you can see it's a reserved multicast address for the RIP. Not in this case. In previous case also, you might have noticed that it is reserved multicast address for the RIP. Then it is not a request because we are withdrawing the routes. So the command should be response, and the value of that command for response is 2. Then it can have multiple route entries. So the route entries that are over here, they will have matrix 16 value because we are withdrawing the routes. Let's say if we are asking for the route, the command value will be request and it is 1. But here we are withdrawing the routes because the route, we have lost the route, and that's the scenario of route poisoning. So here the command will be 2 and the metric value will be 16. So depending upon the command, the metric significance of the metric value will be changed. So that is also one thing to note about, and that's the basic scenario of route poisoning. Now we have something called split horizon. So split horizon is nothing but a specific scenario. Let's say so there are two devices connected in point-to-point channel, but let's say when the device sends to the immediate next node to the device, let's say it receives the RIP packet from the immediate next node of the particular topology. So it will if they are communicating over the RIP, so it will forward the packet to all the other routes, all the other routers. But split horizon prevents that because it also advertises the routes to the device which has already sent the packet. So it is nothing but the prevention of routing loop by sending routing updates to the neighbor from it has received. So it will not send the routing update from the device, so from the neighbor from it has received the route. So that is the specific scenario of split horizon. And then we have something called split horizon with poison routes. So it's just the same as split horizon, but thus the thing is, it is the specific scenario for the route withdrawal. So when we have route withdrawal, so basically the route poisoning, in that case also, let's say we have particular devices who is sending us the poison routes, so we'll not send those poison route back to that device. So that's split horizon with poison route. So these are the specific route RIP scenarios that you must need to be aware with. So after that we have something called timers in RIP. So here is the diagram for per route entries, that each and every route entry will go through these phases. So let's say a device has learned some route, so there will be a timer. So the timer is called update timer, and the default the time interval is 30 seconds. So it will start, and let's say we have received some updates, so it will again start some invalid after timer. And what this timer does is, it is having basically 180 seconds of default timeout period. So let's say after this amount of time the route that is being learned, it will expire. Okay, so it will become, it will not expire, but it will become invalid, and then there is some other processes. Okay, so let's say after this 30 seconds of time, if we didn't receive the any update for that particular route, so it will fall under this invalid route. And if that also expires, so, and in between, if we haven't received the message, so we will start something called hold down timer. If we received the message, we'll restart it. Over here also, if we receive any update within this 30 seconds, we'll restart this timer, and not will not we will not start this timer. And let's say we are here and we didn't receive any message, any update for this invalid route, so we'll start something called hold down timer. And this is also 180-second by default countdown. And let's say if we are in hold down timer, there is no way of going back. So what we will do is, after that 180 second, we'll start advertising the routes with the metric value 60, because we didn't receive any update. We waited for 180 seconds and we still didn't received any updates. So that's why we will withdraw the routes, and that's why we'll start advertising the route with the metric value 60. Now in between, if we receive any update, so we'll discard it. So while we are advertising it as withdrawn route, and meanwhile if we receive some update regarding that particular route, so we'll discard it, because obviously we are marking as unreachable. And then after the expiry of hold down timer, we will flush that entry. And if we have received some what you can say updates, if we didn't receive any update, then we'll remove the route. If we have not received, if we have received any update, so we'll start something called flush after time. So we'll wait for 240 seconds before actually we remove the route. So the first iteration, after the first iteration, if we not receive the route update, so we'll remove the routes. So this is the particular timeline or the phases that each route will go through. So let's look at the RIP configuration in Cisco packet tracer. So this is the basic topology in Cisco packet tracer, and there are 3 routers who are running RIP. So basically the network over here is 10 10 10 1. So this is the default gateway 10 10 10 1, and this is 10 10 10 2, and both of these have /24 /24 subnet mask. And over here we have something called 10 10 21 with /10 10 20 0/24 network. So this is 10 10 21, the default gateway, and this is 10 10 22. So we'll have a communication between these two devices, but for that we need to have RIP running behind these devices. And how we can configure RIP? So to configure it, we can go over here in the global configuration mode. After that, we can just enter router RIP, and now we can just enter the networks that are directly connected to this router 0. So the first network which is directly connected is 10 10 10 0. Then the second network which is directly connected, so these are the 2 networks that are directly connected with it. So the first network over here, fast is an N0/1, which is 2020 10 1/2020 10 0/24. Here there will be 20 20 20 2 or not 2 0/24. Over here 2020 30 0/24. So we can go over here. Then again, from the global configuration mode, we can go router RIP, and then network 20 20 20 10 0 20 20 30.0, and we can directly come to global configuration mode. Okay. We can hold this over here. We can open router 2, the router 2 also. We can go to global configuration mode, then router RIP, router 2. So over here 20.20.20/24, and over here 20.20.30.0/24. So network 20.20 and 30.0. That's it. We can come to privileged executable mode. We can also close this one. We can open router 1, and again for the router 1 we can go to global configuration mode. Over here we can give router RIP, then the first network is 10.10.20.0, and the second network is 20.20.10.0, and the third is 20.0. So that's it. We can come to privileged executable mode, and we can throw IP root. So over here we have this entries marked with R, and what R stands for is RIP. So these are the routes that are being learned via RIP. Okay. So you can see we have this route RIP. So hopefully you have got the idea about RIP, the specific routing scenarios that we have seen. So that's it for this video. Hopefully you have got the idea about RIP, and we'll meet in the next video. Till then, keep learning and keep exploring.